In this presentation, we have talked about elementary particles. The particles which are responsible to constitute an element are called elementary particles or fundamental particles. These particles are not made up of some other. In fact, the size of the elementary particles is lesser than that of an atom. Elementary particles obey either Bose-Einstein statistics or Fermi-Dirac statistics. With the help of the four fundamental interactions, gravitational, electromagnetic, weak and strong interactions, we may classify the elementary particles into four major categories: gravitons, photons, leptons and hadrons. Gravitons are explained by the gravitational interaction, whereas photons are described by the electromagnetic interactions. Leptons are governed by weak interactions and hadrons are described by strong interactions. So on the basis of the four fundamental interactions, the elementary particles are majorly classified into four categories: gravitons, photons, leptons and hadrons. In Greek, lepton means weak, hadron means strong. So this belongs to weak interaction and hadrons belong to strong interaction. Further, hadrons are classified into two categories: mesons and baryons. Finally, baryons are classified into nucleons and hyperons. We are familiar with the nucleons. Protons and neutrons are called nucleons. Their antiparticles, antiprotons and antineutrons, are also called as nucleons. Now we may discuss about them one by one. Now come to the initial statement. In early 1930, the electron and the proton were recognized as constituents of all the elements and hence were recognized as elementary particles. The neutron and positron were discovered in 1932 and the neutrino in 1934. Various types of mesons were found during the study of cosmic rays. All these particles are called elementary or fundamental particles. These particles are not made up of other particles. Now we will go to the classification of elementary particles. Elementary particles could be grouped according to the fundamental interactions to which they belong. The four fundamental interactions are gravitational, electromagnetic, weak and strong. The elementary particles are classified as gravitons, photons, leptons and hadrons based on these four fundamental interactions. Now we may go to gravitons. The particle graviton contributes to the gravitational field. Gravitons have not been detected in the laboratory. However, gravitational interaction plays a vital role in forming stars and galaxies. Next classification is photons. Photons have zero rest mass and zero charge. Photons obey Bose-Einstein statistics and have an integral spin. We know that particles obeying Bose-Einstein statistics are called bosons and are having either zero spin or integral spin. But our photons are having integral spin. The photon's momentum is P equal to h nu by c. We know the energy of the photon E equal to h nu. According to Einstein mass energy relation, E equal to mc square. Therefore, mc square is equal to h nu. mc into c equal to h nu. mc equal to h nu by c. Here mass into velocity mc is our momentum p. This is p. P equal to h nu by c. A photon is generated during the pair annihilation process. An electron plus a positron. They annihilate and the energy is liberated in the form of photon. Positron is the antiparticle of electron. Then next classification is leptons. The light particles like electron and neutrinos are referred to as leptons, since the Greek word lepton relates to lighter. And the fourth classification is hadrons. In Greek, the meaning of the word hadron is strong. Therefore, the strong particles are called hadrons. Hadrons are further classified into two groups and are mesons and baryons. See here, hadrons are further classified into two groups, mesons and baryons. Baryons are classified as nucleons and hyperons. These baryons are further classified as nucleons and hyperons. First take our mesons. Meson includes pions, K particle and eta particle. All these have zero spin and obey Bose-Einstein statistics. First classification is pions. It is a short name of pi meson. There are three types of pi meson and are pi plus, pi minus and pi 0. Now mesons are pions, kaons and eta particle. This is classified into three groups: pi plus, pi minus and pi 0. In the same manner, this is also classified into K plus, K minus and K0. Now, these pions are produced when nucleons are bombarded by other nucleons or photons. Positive pi meson has a positive charge equal to that of an electron and a rest mass 273 times that of an electron. The half-life of pi plus is 1.78 in 10 power minus 8 second, and pi plus decays into a positive muon and a muon neutrino with the release of 34 MeV energy. Next classification is negative pions. These are antiparticles of positive pions. They have a negative charge equal to that of an electron and have the same mass, same half-life and mean life as a positive pion. This is a decay process of negative pion. Next classification is neutral pion. It has no charge. A rest mass equals 264 times the mass of an electron. It has a half-life of 5.5 to 10 power minus 17 second and a mean life of 8 to 10 power minus 17 second and decays into 2 photons. Each photon carries 70 MeV of energy. Then K particles. There are 3 K particles: positive kaon, negative kaon and neutral kaon. K plus, K minus and K0. Positive kaon has a positive charge equal to an electron. It has a rest mass equal to 966 times the rest mass of electron. Half-life is 8 to 10 power minus 9 second. This is the decay process. In 2 different modes, it is subjected for decay. Then negative kaons. Negative kaon has a negative charge. The mass of the negative kaon is almost equal to that of an electron. The half-life and mean life of a negative kaon are identical with those of a positive kaon. It decays into a negative pion and a neutral pion with the release of 219 MeV of energy. Neutral kaon has no charge. It has a response equal to 974 times that of an electron. Then the half-life is 7 into 10 power minus 7 second. It decays in two different ways. These are all the different decay modes. K0 into pi plus and pi minus. Then K0 is decayed into pi 0 and pi 0. Then eta particle. It has no charge, having a response of 1073 times that of an electron. The half-life is 10 power minus 18 seconds. It decays into 2 photon. It decays into pi 0 and pi 0. And this is the final decay mode, pi plus, pi minus and pi 0. Next classification is baryons. Baryons are fermions that undergo strong interactions. Particles obeying Fermi-Dirac statistics are called fermions. Baryons are divided into nucleons and hyperons. Nucleons include proton and neutron and their antiparticles. It is antiprotons and antineutrons. They obey FD statistics. First case, proton. Proton has a positive charge and its value is equal to that of an electron. This is the charge of a proton, plus 1.6 in 10 power minus 19 coulomb. The mass of the proton is 1836 times that of an electron. It has a spin value of 1 by 2. The magnetic moment is 2.793 nuclear magneton. It is a stable particle but can decay inside the nucleus according to the following scheme. Proton is converted to neutron with the emission of a positron and neutrino. Its antiparticle is an antiproton. It has a negative charge equal to that of the proton and has the same mass. The proton and antiproton pair annihilate with the release of about 1870 MeV of energy. Next case is neutron. The neutron has no charge but a mass equal to 1839 times the mass of an electron. Its antiparticle is an anti-neutron. Neutron decays into a proton, electron with the release of an antineutrino. Final case is hyperons. Particles of mass greater than those of the nucleons are called hyperons. Except omega particle, all the hyperons are having the spin value of h cross by 2, whereas omega particle is having the spin value of 3 by 2 h cross. The various hyperons are given below. That's all about the classification of elementary particles.